Welcome to the Explainer. Let's jump right in because today we are looking at something that literally just dropped in the open source AI world, and it is genuinely turning heads. It's a new coding model called ORNITH 1.0, and what makes this totally different from basically every other coding AI out there is that it learns how to run itself. It doesn't just solve coding problems, it actively figures out how to organize its own internal thinking process while it's training. It is an absolute paradigm shift. Which brings us to the million-dollar question we're going to answer today. How exactly does a relatively tiny 9 billion parameter model, one you can run locally on your own machine, end up taking down massive corporate models 3 times its size? Well, it all comes down to a brand new approach to how AI structures its own logic.
Okay, let's dive into this. Here is our roadmap for the Explainer. First, a new open source champion. Second, the magic of Self Scaffolding. Third, stopping the AI from cheating. Fourth, benchmarks, the hard receipts. And finally, how to run ORNITH 1.0 locally.
All right, Section 1, a new open source champion. Let's officially meet ORNITH 1.0. So, ORNITH 1.0 comes fresh out of the oven, released in June 2026 by a research team called Deep Reinforce. This is an open source model family built specifically for agentic coding. That means it's designed from the ground up to operate like an AI agent that can autonomously work through complex coding tasks. Now, it comes in 4 sizes, 9 billion, 31 billion, 35 billion, and a massive 397 billion parameters, all built on top of the already rock-solid Qwen 3.5 base model. Plus, it is released under the MIT license. That means it's totally free, even for commercial use, with 0 strings attached. But for this explainer, we are going to keep it real and focus heavily on that 9 billion parameter version, because that is the one anyone with a decent single GPU can actually run at home. The absolutely crucial thing to understand here is that ORNITH 1.0 is a reasoning model. So before it just impulsively spits out an answer to your prompt, it goes through an internal thinking process. It's a lot like how you or I would pause, step back, and map out the steps of a complex problem before we actually started typing out the final code solution. Moving on to Section 2, the magic of self-scaffolding, AI writing its own playbook. Let's actually slow down for a second because this is the secret sauce. This is where the AI literally writes its own playbook. Self-scaffolding is a training mechanism where the AI learns to write and refine its own organizational rules and thinking process. Instead of relying on a human to code every single behavioral parameter, the AI organically develops its own logic. This is exactly how self-scaffolding creates significantly smarter AI agents, entirely without human rules bottlenecking them. Let's put the old way right next to the new way to really highlight the difference. Traditionally, most AI coding agents come with what we call a fixed harness. Think of a harness like a very rigid set of rules that some human engineer had to handwrite. These rules dictate exactly how the model should approach a problem, how to use specific tools, how to handle a random error, and how to organize its steps. It's incredibly rigid. But over on the right, ORNITH 1.0 does something totally revolutionary. Through self-scaffolding, it learns to write its own harness. It dynamically generates its own playbook for how to be an effective agent. So how does this actually play out during training? Well, picture a continuous loop. In step 1, the model looks at a task, checks out the last scaffold or playbook it used, and proposes a refined, better version of it. In step 2, it uses that brand new scaffold to try and solve the task. Then comes step 3, the reward phase. It gets a score based on how well it did, and boom, that feedback loops right back into the system. So not only does the model get better at solving problems, it literally gets better at building the underlying framework that helps it solve problems. Over thousands of iterations, this creates this incredible feedback loop where the model evolves hyper-efficient strategies completely on its own, bypassing human design altogether. Which brings us to Section 3, stopping AI from cheating and defending against reward hacking. Now, you are probably wondering, if the AI is writing its own rules and grading its own methods, how do you stop it from basically cheating? It's like letting a high schooler write their own final exam and grade it themselves. Total recipe for disaster, right? In machine learning, this is called reward hacking. The model could, theoretically, cheat by just figuring out how to read the test files directly and hard-coding the answers to get a perfect score without doing any real work. To stop this, the team at Deep Reinforce built 3 solid layers of defense. First, a fixed environment that the model absolutely cannot touch or alter. Second, an active monitor running in the background that instantly flags any rule breaking. And third, a completely frozen judge AI that sits outside the loop and acts as an ultimate veto over any rewards the model tries to give itself. All right, Section 4, Benchmarks. The hard receipts, David versus Goliath. Let's see if this whole self-scaffolding concept actually translates into real-world performance. Spoiler alert, it absolutely does. This brilliantly illustrates our David versus Goliath dynamic. Just look at the SWE Bench verified test, which is basically the gold standard for fixing real GitHub issues. The tiny ORNITH 9 billion parameter model scores a massive 69.4. Meanwhile, Gemma 4's 31 billion parameter model, which is over 3 times larger, only hits a 52. ORNITH 9B is punching way above its weight class here.
And guys, this is not a fluke. We see the exact same story play out on Terminal Bench 2.1, testing terminal-based coding agents. ORNITH 9B scores a 43.1, narrowly but definitively beating the much larger Gemma 4 31B, which sits at 42.1. A 9 billion parameter model consistently beating a 31 billion parameter model across the board. That is the real headline here.
But if you're curious about the absolute ceiling of what this self-scaffolding technique can achieve, we have to talk about the massive 397 billion parameter version of ORNITH. It scores an insane 82.4 on SWE Bench verified. That number is a total bombshell because it means the ORNITH family officially dethrones Claude Opus 4.7. This entire model family is clearly no joke. Let's hit Section 5, running ORNITH 1.0 locally, setting up your own agentic coder. So how do you actually get your hands on this thing and set it up as your personal coding agent? It is incredibly straightforward. Step 1, just make sure you have Llama installed from their website. It's a super simple one-click install. Step 2, open your terminal and run the standard Llama pull command for the model. That reaches out to Hugging Face and pulls the GGUF version straight to your machine. It's a relatively small footprint, downloading around 5 to 6 gigs depending on the quantization, so it takes like a minute. Step 3, start a chat interface right in your terminal and just prompt it. Ask it something like, write me a Python function that checks if a number is prime. What you'll immediately notice is that reasoning behavior we talked about. You will see a distinct thinking block fire up internally before the clean code answer actually drops. It's just amazing to watch run locally on your own hardware. And as a bonus, it plays perfectly with open source agent frameworks that use the OpenAI API format, like OpenHands or OpenCode. So what is the big takeaway from all of this? ORNITH 1.0 is one of the most exciting open source drops we've seen in a while, and it's not just because of those crazy benchmark numbers. It's because the foundational approach is entirely different. As the source material points out, teaching a model to build its own scaffolding during RL training is a real research contribution, not just a fine-tune on top of existing work. This is a fundamental leap forward in how we build AI agents. We are officially moving away from human-coded limitations and stepping into an era of systems that optimize themselves from the ground up. Which leaves us with this final, pretty wild thought to chew on. If a tiny 9 billion parameter model can figure out how to rewrite its own rules to punch 3 times above its weight class and beat the corporate giants today, what exactly is this self-scaffolding technology going to build tomorrow? Thank you so much for watching The Explainer, and I highly encourage you to go grab the model from Hugging Face and test out this incredible self-improving reasoning block for yourself.